Hi, and welcome to today's lesson on the gradient of a straight line, the equation of a straight line, and parallel and perpendicular lines. So this video will cover the learning objectives 2.1.1, 2.1.2, and 2.1.3 of Topic 2, HLAA Math. So let's get started. What is the gradient of a graph? Well, basically, the gradient of a graph represents the rate of change. It is a measure of how these y values on the y-axis change with respect to these x values on the x-axis, or how these y values change as the x values change. So the gradient of a line can either be positive, where the line goes upwards, it can be negative, where the line goes downwards, or the gradient can be zero, which means that the line is flat or horizontal, because these y values do not change as the x values change. So the gradient is a measure of the rise over the run between 2 points on the graph, or the change in y over the change in x. And this is shown by this equation here, which, don't worry, it's given to you in your formula booklet. So when we have 2 points on a straight line graph, we write them in the form x1, y1, x2, y2, where x1 is the x-coordinate of your first point, y1 is the y-coordinate of the first point, x2 is the x-coordinate of the second point, and y2 is the y-coordinate of the second point. And then to find your gradient, you substitute it into this equation here, and m is basically the gradient. So now we're going to do an example where we find the gradient of the line that passes through the points minus 5, 2, and 3, minus 14. So we need to assign these numbers here, y2, y1, x2, and x1. So we're going to say that our minus 5 is our x1, our 2 is our y1, our 3 is our x2, and our minus 14 is our y2. So now we can substitute these values in to find our gradient. So we're going to write m, which is the gradient, is equal to our y2 value, which we said was minus 14, minus our y1 value, 2, over our x2 value, which is 3, minus our x1 value, which is minus 5. So minus 4 minus 2 is equal to negative 16, and 3 minus 5 minus negative 5 becomes 3 plus 5, which is 8. So, and then negative 16 over 8 is equal to negative 2. So the gradient of the line that passes through the points minus 5, 2, and 3, minus 14 is equal to minus 2. Okay, so now that we know how to calculate the gradient of a straight line, we're now going to learn the 3 forms that the equation of a straight line can be written in. So these are your slope-intercept form, your general and standard form, and your point-slope form. These equations and these forms are given to you in your formula booklet, but the names aren't, so it might be a good idea to familiarize yourself with their names. So we're going to start with the slope-intercept form just because it's the most common form that the equation of a straight line is written in exams. And we're going to talk about what each of these letters represents. So y refers to the y-coordinate of a point on the graph, and x refers to the x-coordinate of a point on the graph. M refers to your gradient, as we saw from the equation above, but what does this c represent? So this c is basically the y-intercept, which is the point on the straight line where the graph crosses the y-axis. And it's usually written in the form, and the y-intercept is usually written in the form 0 and then a certain value, and it's this value that then is your c. The general standard form is often used in algebra and systems of equations, and it's basically the a, the b, and the d are constants, and once again the x refers to a x-coordinate and the y refers to a y-coordinate on the straight line graph. And it's kind of like a rearranged form of your slope-intercept form, set equal to 0. And then finally, the point-slope form is useful for when you know the gradient and one point on the line. And basically, it's written in the form of y minus the y value of your point would equal to the gradient times by x minus the x value of the point on the graph. Okay, so now that we know the three forms, we're going to do an example. So we need to find the three equations for a straight line passing through the point minus 5, 2, and 3, minus 14. So I use the same points because we calculated the gradient up here, so we can just use this value to write out the three forms. So we found that the gradient was equal to minus 2, so I'm just going to write that out here. And we're going to start off with the slope-intercept form. So we know that the gradient, or m, is equal to minus 2. So how would we find c? Well, basically, we're going to first rewrite this equation with substituting in our m value. So y equals minus 2x plus c. So how would we find this c? Well, basically what we need to do is we need to substitute in the x value and the y value of one of the points on the graph, and then we need to solve for c. So just for simplicity, I'm going to pick this first point here, minus 5, 2. So the y value of this point is 2. So 2 is equal to minus 2 times by our x value, which is minus 5, plus c. 2 is equal to 10 plus c. And then we subtract 10 from both sides, so negative a is equal to c. And then we basically just now substitute in our value for c to get that the equation of the straight line in the slope-intercept form is minus 2x minus 8. Now we're going to do the general standard form. So the easiest way to find the general standard form is to just rearrange your slope-intercept form and set it to 0. So I'm going to take this form here and I'm just going to rewrite it, the slope-intercept form, and just rewrite it here. Okay, so we need to now bring the x and the negative a over to the other side. So we're going to add 2x and add 8 to both sides to get 2x plus y plus 8 equals 0. And then finally, for the point slope form, we keep y the same, but we substitute in the y1 value, which, because we are using the point minus 5, 2, we would write 2, and then we set that equal to m, the gradient, which we calculated to be minus 2 from the first part of the lesson, times by x minus the x1 value, which for this point would be minus 5. So minus 5. And then we can just rewrite this as negative 2 times by x plus 5. And we can expand this out if we want to, but we're just going to keep it in this form given to us by the formula booklet. And so that's how you find the three equations for a straight line passing through a particular point. And you can check your answer by then doing the same steps with the second point and seeing if you get the same three equations, which you should. Okay, so now we're going to move on to the last part of the lesson where we learn about parallel lines and perpendicular lines. So we're going to start with parallel lines. So basically, two parallel lines will have the same gradient. So if I just write out the equation of two lines written in the slope-intercept form, we would get y equals m1, and this one basically represents that it's the gradient of the first line, x plus c, and then the equation of our second line, straight line, would be y equals m2, x plus another value for c. So if the two lines are parallel, what this means is that m1 is equal to m2. This gradient is the same as that gradient. Now, for perpendicular lines, it's slightly different. The gradients of two perpendicular lines are the negative reciprocals of each other. So if we have y equals m1 x plus c, this is the equation of our first straight line, and then we have y equals m2 x plus c. M and m1 is not equal to m2 like it is for parallel lines, but instead m1 is equal to negative 1 over the second gradient. So what this means is that the first gradient times by the second gradient of two perpendicular lines should be equal to -1. And we essentially rearrange this in order to get this relationship where the gradient of one line is the negative reciprocal, or -1, over the gradient of the second line if the two lines are perpendicular to each other. So now we're going to do an example where we write the equation of a line that is parallel to the line y equals 4x plus 2, and then perpendicular to the line y equals 3x plus c, and that passes through the point -3, 4. So we'll start with the first part of the question, this one. So we know that if two lines are parallel, they must have the same gradient. So this is written in the slope-intercept form, so that means the gradient of this line is equal to 4. So the gradient is equal to 4. So if we need to write the equation of a line that is parallel to the line y equals 4x plus 2, that line will also have a gradient of 4. So we write y is equal to 4x plus c. Now, because the question is not specifying what point the line passes through, like the parallel line has to pass through a particular point, we can just assign any value for c that we want. So in this case, I'm just going to pick 2. But I'll show you in this example what happens when we do have to find the equation of a line that is either parallel or perpendicular and that passes through a particular point. So we're going to do this part of the question now. So we know that two perpendicular lines have gradients that are negative reciprocals of each other, and this line is once again written in the slope-intercept form, so its gradient is 3. This means that if the gradient of this line is 3, the gradient of the second line will be, the gradient of the second line will be the negative reciprocal of this gradient. So it would be -1 over 3. So this is what the gradient of the second graph of the second line would be. Okay, and now we're going to write the equation in the form y equals -1/3 of x plus c. Now, unlike in this example, we can't just assign any value for c because the line has to pass through the point -3, 4. So in order to find the corresponding value for c for a line that passes through this point, we need to substitute in these values, the x and the y coordinate of this point. So our y coordinate is 4, so we would write 4 is equal to -1/3 times our x value, which is -3, plus c. So 4 is equal to -1/3 times by -3 is equal to 1. And then plus c, and then we subtract 1 from both sides to get 3 equals c. So then we would substitute this value for c back into our original equation here to get the equation of the line that is perpendicular to the line y equals 3x plus c and that passes through the point -3, 4 is y equals -1/3 of x plus 3. And so that's all for today, and see you next time.